In this video, we're going to work on writing equations from graphs. And if you watched the other video on how to find slope from graphs, you'll recognize the four graphs that I have here. I decided to just use the same ones. Saves me some work and provides us some good examples. But either way, I'm going to go ahead and repeat some of that same work, because in order to write equations from graphs, we're going to have to find the slope. The key part to this is remembering that typically when we're writing equations from graphs in 8th grade, we're going to be writing the equations in slope-intercept form. And again, that is written as y equals mx plus b, where m is our slope and b is our y-intercept. And if you'll keep that in mind as we go through these four graphs, I think it'll make it a lot easier on you to kind of understand why it looks like the way it does. So we're going to start over here. I'm going to call this problem number 1. And in this graph, you can see that it has positive slope. It's increasing from left to right. But just as a little reminder to figure out where we need to start. And I notice a lot of you guys in your quiz did not do something like this, which isn't necessarily a bad thing, but we also had a lot of you who did not successfully write these equations. So I would start by actually writing the equation up here at the top, or on your work, just to give you a starting place. And when you do that, that lets you know that, well, you have two things that you need to find here. You need to find m, the slope, and you need to find b, the y-intercept. So to find slope in this first one, we're going to pick 2 points that we know the line passes through. So I'm going to choose this one, which is a little bit hard to see with the yellow on there. Maybe I'll switch colors to maybe, I don't know, maybe some red here, and that'll be fine. So there's 1 point, and I made a note in the other video that you got to be really careful. You might decide to use this area right here, but if you look really closely, that line actually does not cross or pass through that point. Same thing for something like this right here. So you actually see that there's a small little gap in there. So we don't want to use those two as another point. The only other option is really this point down here. And to find the slope, we simply do rise over run. So I'm going to count my rise. 1, 2, 3, 4, 5, 6, 7, 8. So we have a rise of positive 8 and a run of 1, 2, 3. So I know, just based on that, that my slope, I'm going to write it over here to the side, is 8/3. Okay, so there's part of my equation I already have. I've taken care of m. But now I have to find the y-intercept. And this is actually pretty easy. It's simply where the graph crosses the y-axis. And it just so happens that I chose this as one of my points. It's this right here. You'll notice up here is the y-axis, and that's where it crosses. So it looks like it crosses at 4. So over here to the side, I'm just going to write b is 4. Now that I have these two things over here, my slope and my y-intercept, is just as simple as taking the equation from the top, starting with y equals, and replacing m with my slope, which I found to be 8/3, and leave it as 8/3. Don't make it a mixed number. X plus b, which is 4, and there is your equation for the graph of this line. Moving on over here to problem number 2, or graph number 2, we're going to take the same approach. I'm going to start by writing the equation again. It's just a good habit to get into. And that reminds me I need to find m, which is the slope, and b, the y-intercept. So I'm going to start with slope. Baby steps here, just one thing at a time. Okay, I'm going to choose 2 points that I know the line passes through, or that I'm fairly certain the line passes through. Switch back to red real quick. I'm going to choose, this one looks like a good point, and this one. Now this time, notice that this point here, if we start from left to right, is higher than this one here, which means we're going to be going down. So we have a drop instead of a rise. Let me go back here. 1, 2, a drop of 3. So we have -3 as our rise, so we have a drop here. And then our run is actually 1, 2, +2. All right, so over here to the side, I'm going to write slope m is equal to -3/2. I'm going to put the negative with the 3. And then I'm going to look for my y-intercept. On this one, it's a little bit trickier, I'll be quite honest. I probably didn't pick the best example, so we're going to pretend like this is right, just for the purposes of making this simple. You can see here that the y-intercept is located right there. You know, I'm not sure exactly what that is. It could be, looks like 1/2 or 0.5, but it also could be 0.6, could be 0.4. For the sake of keeping this simple, we're going to go ahead and agree that that is 0.5. So I'm going to list that over here. If you want to put 1/2, that's fine too. So if I take both of these and basically plug them or substitute them into the template, I'm going to start with y equals, my slope is -3/2, x plus 1/2. And there is the equation of that line. Okay, moving on down to this graph, we're going to call it number 3. This is one of those, it's a special case. All right, so we have a horizontal line here, and if we approach it the exact same way we've been approaching these others, let's first start off by writing the equation, y equals mx plus b, at least starting there, even though that could change. Just try to have that same approach with each equation. I'm going to first try to find the slope. So I'm going to pick 2 points that I know the line passes through. And there's plenty of options here. We could pick this point. Let me switch back to red again. This point here and, you know, this point. Really doesn't matter. You know, you ask yourself, well, how far up do I have to go or how far down do I have to go? Well, you really don't have to go up or down, because this is a horizontal line. So that means that our rise that we would normally have is just going to be 0. And then our run, if we go from left to right, will be 1, 2, 3. So our slope, I got plenty of room down here. So right here, remember our rise was 0, our run is 3, and 0 divided by 3 is 0. And then our y-intercept, this line does pass through the across or over the y-axis, and it's going to be right there. It looks like that's at -1. So b is equal to -1. And if I take these values and substitute them into the template, I get y equals, our slope is 0, x minus 1. Or you can just write it, since 0x right here basically becomes 0, we have y equals -1. And that is usually what you're going to see in the case of a horizontal line. Then we have example number 4. This is definitely different than the other ones. Typically, we would start by writing y equals mx plus b because we expect it to primarily be in slope-intercept form. Unfortunately, in the case of a vertical line, the equation is actually written x equals some value. And the value, it's pretty simple once you remember how this works for these vertical lines. The value that we have here that we don't know is basically where the line crosses the x-axis. Okay, the x-axis being, of course, the horizontal axis. So if we're looking along this axis right here, the blue vertical line intersects the x-axis right here, which is pretty obvious. And that looks like, oops, it's not what I wanted. Looks like it's at -3. So our equation becomes x equals -3, and that is it. So keep these things in mind as you're working on some of the additional problems, especially these special cases with horizontal and vertical lines. And if you need to go back and rewatch the video again to kind of get a better understanding of what's going on, please do as many times as you need. And also feel free to pause it along the way if it's too fast for you.